Hello, everyone. Thank you very much for coming. It's nice to see all of you in person and in Zoom. So today's very special lecture from the AI lecture series is brought to you by the Institute of Computer Graphics. And I would like to let Max try to introduce the speaker.
Yeah, thank you, Oleg. So it's a great pleasure to introduce our today's speaker, Johanna Schmidt. I know Johanna for quite some time already. Johanna did her master's and PhD at TU Vienna, and then after that moved on to be a scientist at Austrian Institute of Technology. And in 2016, she finally moved to VRVis. So VRVis is a research center for virtual reality and visualization. And there she is heading the visual analytics group. And she's doing as her research, she's focusing on large multidimensional data, the visualization of this kind of data. And with this, I'm really looking forward to Johanna's talk. Johanna is going to talk about visual analytics for large-scale IoT data. Johanna, we're looking forward to your talk. Thank you.
Thank you very much, Mark. Also, thank you very much for having me here today. That's really great. Really nice that I can introduce our work here in Linz. First of all, I would like to start with some advertisement, of course. So who are we and what are we working on? So the VRVis is a research center, and we are located in Vienna, in Austria. And as a research center, we are not affiliated with a university. So that's a little bit of difference to the university setting you have here. As a research center, we are organized as a company. And as such, we sit in between universities and companies. This is very similar to the Fraunhofer concept that is well known in Germany, and in Austria we also have the AIT, which is very similar. So we are the goal of the work that we do is to transfer the research from universities to industries, and also there should also be a loop back. Because with our company partners, we are experiencing actually very interesting problems, very interesting research questions, and we would like to bring those questions back to the universities. As I already said, this concept is very similar to Fraunhofer and AIT, but as a VRVis, we are much smaller. So we currently have about 70 employees. The AIT has more than 1,000, so we are, of course, a little bit smaller. About 70 employees sounds like that we don't know how many people we are. That's not the case. It's just there's a high fluctuation because of students, and that's why it's easier to say about 70. The research of the VRVis, of what we do, is targeted towards everything where you need to transfer data into images by using the computer. And that touches a very broad range of applications, also a very broad range of techniques and research fields that we need to work on. Of course, we need to have knowledge of computer graphics and visualization, but we also need knowledge in rendering, in virtual reality, in computer vision. So everything has to come together to provide ideal solution for our customers. And here are some of the results that we produced at the VRVis. The VRVis now exists since more than 20 years. We had our 20 years anniversary during the pandemic. Unfortunately, that would have been a very nice celebration. And here is a list of company partners that we are working with, and also research partners that we are working with. And this graph shows a little bit the development over time. So over time, basically more and more company partners joined the consortium, and also more and more research partners joined in. The VRVis is organized as a so-called COMET center, which means that we are funded by the Austrian state, but we only get funding if we have company partners willing to pay for the research. So a COMET proposal, so we have to write a proposal every 8 years to get a new money for the new funding period. And in every funding period, we have to find a group of company partners that is willing to work with us and is willing to pay for the research. And then the FFG, that's the funding organization, puts in additional state money so that we can fund our research. That's roughly the model, how it works. And we have to have both. We have to have company partners and we have to have research partners, which are mainly universities, because we have to use the knowledge from the universities, but we also are supposed to bring back the research questions from the industry partners to the universities. From the company partners, you can see a strong focus on Austrian partners, of course, because we are funded by the Austrian state, but there are also some international companies to be found here. With 70 employees, we at some point had to decide how to divide people at the VRVis into groups, because with 70 all in one bunch, that would be a little bit too much. So we currently have 4 research groups. Let's start with those 2 here. Oh no, with that one actually, with area 3. So in the area number 3, colleagues are working on reconstruction on the one side, so how to produce images out of laser scans. There's one example here of a tunnel in Austria, because tunnels need to be inspected from time to time. And it's important to detect all the cracks and damages in the tunnel walls. And before that, they had to close the tunnel. And then it took them several days to inspect the whole wall. And now they are actually doing it like that they use a car with a laser scanner on top. And then they drive through the tunnel, takes 5 to 10 minutes. And then they use the laser scan data to analyze the tunnel walls on the computer. And only in cases where it's not so clear, then they have to really drive to the tunnel and inspect the wall itself. But the whole inspection is actually done on the computer nowadays. And the VRVis contributed to this software for the tunnel inspection in Austria. So that is done in the one research group that we have. And another project they work on is a combination of simulation and visualization. So here they have some very large 3D model of some landscape, city, or even larger. And then they can run a flooding simulation. Flooding might be because of a river, might be because of heavy rain. And then this simulation can be interactively steered. So they can interactively change the buildings, for example, or they can build barriers and then see how it would affect the flooding. Or also the other way around, if you have a barrier and it would break, you can make it break in the visualization and then you can see how it affects the simulation. And for this, they need the computing power of the graphics cards, and they're working a lot with rendering and GPU programming. So this is done in area 3. Here they're basically working on 3D data. This is a larger image of the flooding simulation. In area 2, they're mostly dealing with medical and biological data. So they have 3D data, volume data, MRI, CT data of mice mainly, and brain structures. So that's done in area number 2. And I actually don't have a picture of area number 4, unfortunately, but in area number 4, they do research on VR, so on how to present and how to render and how to interact with data visualizations in 3D, in VR, and also in AR. And what is missing is area number 1. Area number 1, visual analytics. This is the area where I took over the lead in 2020, so a little bit more than 2 years ago. And in area number 1, we deal with IoT data. So our company partners are from the manufacturing industry. They collect a lot of sensor information, and they actually would like to better understand their production processes. And for this, we support them with analytics dashboards. So we create software which they then use to analyze their data and to analyze their own data. So in very rare cases, we also get data, but usually we support them with software. And then they use this software to analyze their production data. And our team is, we are currently 6 people, will grow soon to a little bit more than that. And our main research focus is time-dependent data. So IoT data is always time-dependent. That comes from Industry 4.0 applications. And our main task is the creation of interactive dashboards that our company partners can use to analyze the data. And here is a quick demo on how that might look like. So, for example, here we have a bunch of time series data. Time series data means that it's some sensor data that has been recorded over time. So there is some temporal component here. So here we have data from 1 year, 2014, and different parameters. So here, for example, we have temperature. So here we have some temperature curves, for example. The data has been anonymized. So the names that you can see here, like Bright Country, Eastwood, Fantasy Town, and so on, these cities do not exist, of course. But the data has been recorded in real scenarios, and the names have been changed afterwards to not reveal the origin. And here, for example, some temperature curves have been recorded indoor and outdoor. And with the dashboards that we create, people can very quickly browse through the data, compare it, find out, for example, missing periods in the data, also faulty values, and check for correlations, for example. So in this view here, if we have a look just at the temperature curves, then the colors tell you whether the values at a certain point are above or below the general mean at that position. So if the data here is whitish, then it is according to the mean that is in the data. If it's blue, then it's below, and if it's red, then it's above the mean. And since we're looking at temperature curves, that means, for example, that these time series here have higher temperatures than the other temperature curves, or here they have lower values. And also the time series are sorted according to correlation, so that you can immediately see patterns in the data. Time series that behave similar, and time series that are different according to the others that are in the data. And black means missing values. So something that you can also very quickly detect here is if there are periods of missing values. And like here, for example, the temperature curves for indoor and outdoor temperature in Eastwood both have missing values at the same period in time. So obviously here something went wrong with the recording in Eastwood. And we could, for example, search for Eastwood now. If the laptop lets me search something. And then we can see other time series in Eastwood where data is missing at the same point in time. If there are any people in the room who know what's wrong with my laptop, I'm very happy for suggestions. So whenever I type on the left side of the keyboard, screen gets dark. So as a computer scientist, I have no idea what's going on. If someone has an idea, I'm very happy for any ideas what to do. Why do we do this? Of course, it's fun. So our data is about creating images out of data and enabling our customers to have a dialogue with the data, to inspect it, to see patterns, to see correlations, also to get an idea about patterns that they didn't know about before. So really to find out something about the data that they were not aware of. And this is really interesting to work with. And it was also confirmed in this paper by Posada et al. In 2015, where they actually said that visual computing acts as a key enabling technology for Industry 4.0. So that they identified several technologies that you need in the digitalized industry. And of course, there are things like IoT data recording. That's something you need. You need industrial big data analysis. You need intelligent robots, but you also need visual computing as one major part, because otherwise you're not able to inspect your data. And that is also the case why it's very rewarding to work in that area and to really provide people with software they can use to analyze their data. And we also got some feedback from our customers. So of course, we are asking them, we are in very close collaboration with them, and we are asking them, how do you use the software and what are the patterns you detect? How do you use the software? And they actually always mention that the speed improvement is the most important part why they would use visual analytics for analyzing their data. So in one example, these were engineers from the RAI Magnesita, so they're producing big Austrian companies. They produce stones that can sustain very high temperatures. So these are the stones that are afterwards used by the first, for example, to build the ovens where they produce steel. And they said that with visual analytics, they were able to inspect data from 1 year within several hours. Before that, it would have taken days, really with an S at the end. So before that, they were using Excel, and if they have a data set from a whole week, that's several gigabytes of size, so they had to split it, and it took them several days to analyze this data. But now they can load it into one dashboard and see the whole data at once, and then it just takes them a couple of hours, and then they know everything they want to know. And also with visual analytics, they were able to detect some unknown patterns which they weren't aware of before at all. So for them, this also a little confirms a little bit what was written in the paper before, that you actually need visual tools to understand such big data sets. But of course, we were questioning ourselves. As a research organization, you're always kind of hunting after the money. So we're always asking for research projects. We are asking for collaborations. So if visual analytics is such an important factor, why isn't it the other way around, that the companies are searching for visual analytics solution and asking us for collaboration? What's going on here? Why is visual analytics not included in every project yet? And we summarized our findings in the paper last year, where we reflected a little bit on our experience on doing research projects together with industry partners in the manufacturing industry. So we teamed up, Lena from Fraunhofer, Wolfgang Eigner from the University of Applied Sciences in St. Pölten, and me. And we collected a bunch of visual analytic projects that we did together with industry partners in Austria and in Germany. And here are some results. This is a dashboard very similar to the one you have just seen. So that was created by the VRVis. And there are some examples from Lena's project, this one, and from Wolfgang's project. So it looks quite similar, actually. In all cases, we had visual analytics dashboards. We had a way to make data visual. They were interactive in most of the cases, so people could interact with the data. They could detect patterns. They could better understand the data, actually. Some larger images. This is an example from one of Lena's project they did at Fraunhofer. Here they provided a parallel coordinates plot. If you haven't seen a parallel coordinates plot yet, you would use parallel coordinates if you have several different attributes in your data. And then you can place the axis in a parallel way. So if you think of a scatter plot, then it's usually a 90 degrees angle. But if you have parallel coordinates, then you place them side by side. And then every data point becomes a line. And then you can detect groups that behave similar in the data, or you can also find relations between one variable and the other. And they used it for, so there were engineers from engine design, and the engineers used it to better understand their engine designs and to find out which engine design would work better in reality. And here's an example from Wolfgang's project. They analyzed log data, so textual data, and provided an interface for people to better understand how a machine is behaving, if there are any errors in the operation, and which types of errors, and do they always occur at the same time. So here, for example, it seems to be that there's a cluster of errors here in the afternoon and one during the night. So they wanted to find out temporal patterns and so on. So we had 13 projects where we had visual analytics included together with company partners within the last 4 years in 2 countries, Austria and Germany. And we first checked what type of data is mostly used in these projects. And there you can see a large amount of data being just time series data, which is not surprising because we work in Industry 4.0 projects. So IoT time series data is something that is very common. And then we have a little bit ensembles, which comes from simulation data and AI models, which is becoming more and more prominent, obviously, where company partners wanted to better understand how their AI models behave. Users were mostly engineers, so they didn't have either no or just very little experience in data visualization. And then we analyzed what type of visualization techniques we actually used in these projects. And here we found out that we actually had to rely mostly on basic visualization techniques. So we had to use mostly, scatter plots, line plots, bar charts, heat maps. So representation that are easy to understand. And that is mostly because the users were not so experienced in data analytics and didn't have also that much time to dive into all these applications. So we had to stick to very basic representations actually. And these were the lessons learned and also the reasons we found out why visual analytics is not used so often in projects nowadays. I will just concentrate on 2 points here. This chart shows you, because here we have the 13 projects that we looked at, and the numbers here show in how many of these projects the lesson learned occurred in a way. And so actually this one, partners are interested in, committed, and solution fits the environment, are the 2 lessons learned that appeared in basically every project that we looked at. And I mean, the first one is not surprising. You need company partners that are interested in data analysis, that want to learn something from the data, and that also are willing to invest some time to get used to visual representations. That was a very important point for the project to be successful. And it also occurred in all projects, basically. And the second one that was very important was that the solution should fit the environment. And this is something that I think will become very important for data visualization in the future, because in many cases, the solutions we offered were standalone applications. And it's really a problem if the solution you provide to the company needs its own environment and doesn't fit into the workflow that people normally have. So in the future, I think for data visualization solutions, it will become more and more important to be web-based, to fit into cloud environments, because this is what companies are usually working with. And this is what they're used to. And also engineers don't like to switch in between applications that much. So they would like to stay within one workflow. So this is an important lesson that we found out, and I jumped over that one because this is also an interesting thing we found out, is that not in all cases, as you can see, but in at least 10 of the 13 projects, we started out with a data visualization and visual analytics project. So it was started like, we need a visualization of our data. We need to do an analysis. We said, fine, we can do that. And then the project started. And then we asked for the data. Is the data, where do you store the data? Can we have it? We need to create some prototype. And then the question was, we have to find out where the data is stored. We have to find out which data we actually need. The data is stored among 5 different databases, and we have a lot of missing values, and we actually don't know how to handle that. So in 10 out of 13 projects, visual analytics and analysis project actually turned into a data engineering project, where we first had to help the companies to organize their data in a way so that we can do an analysis afterwards. And that's quite interesting, but it seems that in many cases, we are more running into data problems than actually analysis and visualization projects, because now we have all the data visualization techniques that we need. So if the data is there, it's easy to do a nice visualization out of it. Also, it's great to do an analysis afterwards, but in many cases, the data is not available in a format where you can use it for analysis. And that's an interesting lesson learned, and I think that's something that will be relevant for all people working in data-driven projects in the future. And yeah, so the conclusions from our study were that we still have a gap for interactive visualization to be used on a daily basis. The integration into existing environments is an important factor, and we experience data problems in a lot of our projects. And another thing that we are also dealing with on a daily basis, and that's quite interesting, is trust. So in many cases, our company partners, the engineers, at some point when they are skilled in using an interactive tool and in interactive visual analysis tools, they ask themselves, can I actually trust what I see here? And I will give you an example on how we had to deal with this. Because we offer our, let's switch to temperature again. We offer our customers the possibility to compare different periods. So if we use maybe something where we don't have that many missing values, so like here we have the temperature curve of a city, for example. And we see some higher temperatures in the summer, lower temperatures in autumn and winter. And let's compare that. So for example, let's select the time period. That's not the selection I want to have. So in the tools that we provide, as you can see, you can use several different selection mechanisms to concentrate on certain parts of the data that are of interest. So now, for example, I selected part of July and part of October and November. And then we can look at the histograms, and then we see that there's a difference in temperature here. So we have lower temperatures in autumn and higher temperatures in summer. It's not surprising, of course, but just to give an example. And if we look at the histograms here, they're plotted on top of each other. So you can see the differences here. You can see the higher temperatures, you can see the lower temperatures. And then before that, I think, can we deactivate that? Yeah. So before that, it looked like that. And then at some point, the engineers asked us, I mean, it looks kind of different, but can I really trust this visualization? And can I, like, if I have to write a report now, can I write a report like that these two periods are clearly different? And then we had to admit that just from looking at it, it might be hard. So what we included is we included some statistical tests. And now the statistical, so there's a t-test and an f-test, and t-test that checks for the means and an f-test that checks for the standard deviation. And now the tests also say that these two distributions are actually different. And now people know that they can actually trust the visualization. And that's currently a huge topic also, because at some point, I mean, visual analytics tools are really great to detect unknown patterns in the data and to structures that they weren't aware of. But at some point, people have to come to a decision and have to draw conclusions from what they found, and they need some sort of trust in here. So currently we are including more and more statistical tests and other means, so that they can really also trust what they see. So that was quite an interesting experience to learn that just seeing the difference is not enough. They also need some evidence here. And so this is what we are currently working on, and we are facing another very interesting problem at the moment, because we have a national research project going on. This is funded by the FFG again. It started in 2021. And we have two research partners. We have the TU Wien. So the TU Wien also leads the project, and we are the second research partner. And we have two company partners, one for the HACOM Time Series GmbH. They are responsible for data engineering, data storage, and Vibro Concept, they are producing sensors. And in this project, we equipped hydropower plants in Austria with sensors, because the hydropower plants in Austria are also not only in Austria, also in whole Europe, they are really, really old, because they were built long time before any solutions for IoT data and digitalizations have been developed. So partially hydropower plants are 50, 40 years old. And the question is now how to nowadays equip those plants with sensors and with sensor measurements to get some data-driven evidence of the health of these machines. So to basically do predictive maintenance here. So you would actually like to know the health status of the machine very much in advance before it stops working. And the interesting thing here is that we actually do not know which sensors are suitable for doing predictive maintenance. So we started out by actually not we, so that was a huge part that was done by the TU Wien, because we are computer scientists, we have no clue on how to install electronic devices somewhere. We'll just break something. So that was done by the TU Wien. They installed 18 sensors inside the machine, because you have to think of a hydropower machine that's kind of a closed area, because there's water running and everything. So after this machine is closed, you cannot look into it anymore for several months, as long as this thing is running. So they had to install 18 sensors in there. And from the hydropower plant operators, we got another 35 and 12 channels. So in total, we had 65 sensors that measured the current state of the machine. And what we didn't, so this is how it looks like, how you can imagine how a hydropower plant runs. We have two machines. The blue one is the machine number 1, the greenish one is the machine number 2. And for many, many times, they just do nothing. And then at some point they are started, and then they are stopped again, and then they again do nothing, and then they are started again and stopped again. This just shows that hydropower is mostly used in Austria to regulate the energy demand. So the main energy demand doesn't come from hydropower plants. The hydropower plants have to jump in when there is a high demand. And this is what you can see here. Obviously, there was a high demand, so they started producing energy, then they stopped again, and then they started producing energy again. And also they produce more energy in spring when snow melts, and less energy in autumn and winter. But unfortunately, hydropower plants were not made for this type of operation. So starting them, stopping again, starting them, stopping again, this is very damaging to the machine. And the TU wants to find out with which sensors you can actually measure the damage here in that state when it has to start and stop again. And we thought, okay, that's really a nice project. Let's let's do some analysis here. And we measured from December 2021 to August 2022. And data was collected, was stored at the TU Wien, because it's also this data is very valuable. It doesn't, it's not allowed for the data to leave the TU Wien. And we measured, and at some point we already said, okay, this is going to be interesting. And then at some point in June, July, the TU asked us, can you do an overview of what we already have? And then we looked at the data and we ended up with 75 terabytes of data. And we were like, okay, probably not. There is no tool where you can load this huge bunch of data and get an overview. So actually we recorded more than 200 gigabytes a day and more than 9 gigabytes per hour. So that's really, really a lot. And that's also the reason why we couldn't transfer the data through the network anymore. So we had to store it locally inside the power plant. And from time to time, the storage was replaced because it would not have been possible to transfer 9 gigabytes per hour over the network, because the plants are in some rural area, somewhere in the mountains. There's no network connection that can transfer that amount of money. So our data was actually transferred via train, not via network, because it wasn't possible otherwise. And after ending up with the 75 terabytes, we started to do some research on what we could do, because also our tools that you have seen before, we are not able to load 75 terabytes, no chance. And there is a nice survey also, which was done by Michael Behrisch in 2018 on business analytics tools. And they also challenged them in terms of data set size. So here are some very prominent names like Microsoft Power BI and Tableau. These are software tools that you might come across if you start doing visual analytics and especially business analytics. These are kind of the leaders in the field currently. But if you have a look at the data set size, then after roughly 10 gigabytes, all the tools reach a certain threshold and it's not possible to load large data into these tools again. And this is also the reason why we are currently looking into new ways how to visualize data, because also with our standalone tools, we've reached a dead end now. So we have to look for new ways how to deal with such large amounts of data. And that's why for the new research periods, we would like to focus on progressive visualization. So how you can include visualization in web-based environments where you don't load the full data set, but where you only load batches and then update the visualization iteratively, so that you are kind of able to deal with such large amounts of data, because this is what the main challenge I think that we will have to face in the near future when it comes to IoT-based data. And I would like to end my talk with an advertisement. So if you liked the topics that I was talking about, and also that we are dealing with at the VRVis, we were doing research on visual computing, there is a very nice event in 2023, the Visual Computing Trends. It happens in Vienna. Participation is free, only registration is required. We are going to have 4 very interesting talks, and it's a full day event and a very nice chance to visit Vienna, to also visit the VRVis, to hear interesting ideas about the future in several different topics. So it's about creative AI, scalable visual analytics, what I just talked about, reconstruction, and explanation of research results. So if you're interested in the topics, please consider the event. It's a very nice chance to visit us at the VRVis. And with this, I would like to thank you very much for your attention and close my talk. Thank you very much.
Thank you for your presentation, for showing us these challenging problems and your wonderful solutions as well. I'm pretty sure we're going to have questions. So who would like to start? Yes, please. Yeah.
Okay, so as I have seen in this presentation, these tools provide the ways to visualize and the data, but do they also include any algorithms or tools that allow to automatically analyze the data and automatically draw some conclusions?
Not yet. That's it's a very good question and kind of touching a weak spot of the tools. So we have very simple analysis included in our tools, which is basically regression. So you can do a simple regression analysis to find out which parameters in your data set might be suitable for predicting some other parameter. But we mainly focused on the visual representation and then left the analysis to the domain experts. Like they found something interesting and then they could do some further analysis afterwards. And I'm not that happy with the situation. I think it would be valuable to have more analysis included here and also to be able to include like models and things like that. So we are planning into that direction, yes.
Thank you. Well.
Hi, thanks for the talk. You mentioned the progressive visual analytics. Are any of the off-the-shelf tools you had in the chart that support like high amounts of data already support progressive visual analytics?
You mean how much data could be handled with progressive analytics or?
No, if they already support like showing results intermediately while fetching the data.
So from the tools that I mentioned here, they don't offer anything like that. So these are really standalone tools. Apart from Kulik View, this also has a web-based version, but they would just load all the data into the browser or into the tool. There was a very interesting idea for a framework presented at the VIS conference this year, where they extended the Vega library to a web-based progressive Vega library. So it seems that research is going on into that direction, but as I've not seen any tool that is ready out of the box to be used that would support that.
Thank you.
Is it okay? Just because thank you for the talk. Just because you briefly mentioned Greiner Big Data Viz, is there already a publication on the tool itself?
This one, yes. This was published by Michael Behrisch, and it was published at the VIS conference 2018 in Berlin. And it's about commercial visual analytic tools. So if you Google Behrisch visual analytic tools, then you will find it. Otherwise, I can give you the link afterwards.
Okay.
I think you meant the VRVis.
This is a different
Greiner Big Data Viz.
The VRVis. Oh, sorry. That one you were talking about.
Yes, exactly.
Sorry, I misheard that. Not sure. I would have to ask Wolfgang, and I would have to check my sheet. I think they didn't publish it. No, it was a web-based tool. So Greiner is a paper production company in Austria, and the title of the project was Greiner Big Data Viz. But I think they didn't produce a publication out of that. No.
Okay, thank you.
May I follow up with a question? So, I mean, you talked about scalability and obviously the data moved to the cloud, AI largely moved to the cloud. So is VIS also going to move to the cloud, which means that it's going to be web-based because it doesn't make sense to load it locally?
I think we have to. Yes, I think we have to. So Jean-Daniel Fekete gave a very interesting talk at the Visualization for Data Science Symposium at the VIS conference this year. And he actually said, to quote him, he said that if visualization doesn't become progressive and scalable, we will become irrelevant. And I think he's right to some degree. So I think we have to consider moving to the cloud, becoming web-based, just to fit into the workflow and also to be able to deal with these large amounts of data. Yes, I think so. I think there was a question over there.
Thank you, first of all. This suits quite well after this question. Since you have all these amounts of data and they need to be transmitted and they need to be stored somewhere, and you said you want to move all these applications to the cloud and make them web-based, did you also run into security issues? You were talking about trust from the engineers. Do companies really want to part with their holy data and have it uploaded into the cloud terabyte-wise?
Yeah, very big problem. I mean, the storage solution that we've chosen for the hydropower data, that one where we use the TU as a data storage, and we are still not allowed to move any of the data that is stored at the TU somewhere else. So they're really, really picky about the data. In all cases, we have to sign very strong NDAs and we are not allowed to give anything away. This is the best I can show because it doesn't tell which hydropower plant it is, and it just shows some rough numbers. I wouldn't be allowed to give this data away. This is really, they're really, really picky about it. On the other hand, and this is something they're not aware of, is that cloud providers, public cloud providers, they are certified and they have very, very good data security regulations. And I think this is also because in the hydropower case, they were thinking in a very conservative way, like if we store it at the TU, then it's secure, which is also not true. And for cloud providers where they have certificates, where they have very strong regulations, I think it's very secure, and it's just this knowledge of having data in the cloud is fine, needs to be spread a little bit. I think it's fine if you choose the right cloud provider. It's secure, yes.
Yeah, I can confirm that. I saw that now multiple times that big corporations, they start to trust AWS and Azure and so more than their own security department. So they're shutting down their servers and pay large cloud providers to like keep their data secure. There's a huge change happening, I guess, in industry now.
Maybe they don't change their sysadmins. I don't know. Could be.
Sure. Yeah, sure.
You said about Industry 4.0. Can you explain a bit more about what it is?
Yeah, I don't get the other numbers right. I think Industry 1.0 was the steam operated trains. 2.0 was manufacturing on the, I don't know the English term, if you have this large band of moving band and people operating. 3.0, I don't remember. 4.0 is digitalization. So whenever it comes to integrating a digital solution in industry, that's 4.0. And now there's 5.0, which also includes robotics. So this is kind of the development of the industrial production where it became more efficient, more elaborate and similar.
Thank you. Yeah.
Thanks. As a follow-up to the question about keeping the data secret,
how much do the companies also want to keep the results from your collaboration secret, and how does that affect how willing they are to publish the results together with you?
Yes, it affects us a little bit, but it's usually not a problem if you do not reveal the origin. So if you don't tell anyone which power plant it was, you can say it was a hydropower plant in Austria, but you're not allowed to say which one. And since there are more than 100, it's kind of anonymous then. And usually in a publication, you use aggregated data, and that's also fine for them. So if it's aggregated and you don't reveal the origin, then they're mostly fine with it. And especially if the results are nice, then they're also happy to contribute to a publication. So that's usually not an issue. We have very rare cases where we were not even allowed to tell anyone that we had a project together with this company. Then it would have been very hard to publish something. But in most of the cases, using aggregated data and so on, it's fine.
Okay, I think I have a question, maybe a more of a light-hearted one. So working with actual industry seems like a very tight spot, especially when you're working with visual analytics, where there should not be like exact requirements toward the tool, because people don't know what they want to find. How do you approach designing such tools? Any wisdom you could share?
It's usually a very close collaboration with the industry partners, with a lot of meetings, with a lot of discussions, where we also have to learn the terms they're talking about. Because if you talk to domain experts, then they usually have a very narrow thinking of their domain, and they're experts in what they do, and they use their own terms. And it takes some time until you can think in their environment and terms and what they are talking about, because we are computer scientists, so I have no idea of how to produce stones. So it really takes some time, but it's a lot of communication, a lot of basically human-centered design, where you really iterate a lot, produce prototypes, try to find out if this is correct. So it's usually not a straightforward path. It's some forth and back and iteration, and takes some time, definitely.
Right, thank you. Okay, so I guess one more question. We had already quite a discussion. Okay, in the Zoom maybe? Okay, there's one.
I can can read it. I do have an additional question. When introducing VRVis, one of the units mentioned computer vision to deal with human vision modeling. Yes, I hope I can do that, because I'm neither an expert in computer vision nor in what the group is working on. Let's see if I can find a good example. So they're dealing with biomedical image informatics. That's the area they're working on. And they mainly have things like that. So they mainly have CT images, MRI images, and also a little bit of industrial images, because in industry you can also have CT inspections and MRI inspections. So it's usually volume data, I would say, either image-based or you really have the 3D volume. And they use AI-based techniques to detect patterns in these images. So that's roughly the work they do. But I would really recommend, if you're interested in this area specifically, I just showed you, it's the VRVis homepage, then biomedical image informatics, and then you can browse through the web page. And if you have an idea of computer vision, then probably you're more familiar with the terms here. But it's mostly medical and biological images, I would say. Hope that answers the question.
Right. Thank you very much once again for presenting your work and also the field in general, because we haven't had anything on the VIS so far. Thank you very much for your presentation. and good luck with all your work. Thank you very much.
Thanks. Thank you very much.